Welcome to yet another exciting educational video brought to you by Christ Lord Tutors. Today we'll be looking at MTH 112 rules for differentiation, and this math class is tailored towards National Open University of Nigerian students who are offering this course. So in today's video, we'll look at differentiation of composites and rational functions and rule combination. Under our learning objective today, we'll be seeing identifying composite functions and apply the rule of the chain rule correctly, differentiate functions involving nested expressions, square roots, powers, exponents, and trig inside algebraic functions. Number 3, combine chain, product, and quotient rules in a single problem. Number 4, simplify derivatives step by step and interpret them. And finally, we'll practice with examples and short-term quiz. So sit tight as we proceed in this video. If you'd like to subscribe to our channel, kindly subscribe to Christ Lord Tutors for more of our content. You can also share the videos to your friends. So chain rule. So the chain rule helps us to differentiate composite functions inside other functions. For instance, if we have y is equals to f of g, again g of x, nested. This function is inside a bigger function. This function g of x is inside the function f of g of x. Understand? So to differentiate it, dy dx is equals to, we'll differentiate this bigger function outside first of all, and we'll also differentiate the smaller function inside. All right, so we'll multiply the two of them. So let's just do a practical example. If we have y is equals to x squared plus 1 all raised to the power 5, like this. First of all, this is defined as a function, where the function inside is this quadratic expression here. Let me call it u. So I'll say let u, which is the function inside, be x squared plus 1, and the function outside y is equals to u raised to the power 5. Agree with me that y is a function of u and u is a function of x. We actually introduce this u to just show this chain of functions. We introduce it to show the chain of functions. So if we want to differentiate this straight away, we can just say dy dx is equals to, differentiate this one first. So I have du dx times dy du. Okay. Now when you're writing this out like this, you see that the du here and du here tend to cancel out, so that I will still have dy dx equal to this. But that's not the sense. It's just for you to know that when you're writing out the expression, whatever chain of functions you are writing out, ensure that the final output will still give you something like dy dx. No, but you are looking at them in isolation. So if we differentiate du dx here is 2x from our previous video. You can check the previous video pin here. Our previous video, you see that differentiating this one is the power and our exponent of this x. So multiply the power by the coefficient and at the same time reduce the power by 1. So I have it as 2x here. This one is a constant, it's giving me 0. Then times, differentiate this one again. The power, 5 times 1 is 5. And if we also reduce this power by 1, you get u raised to the power 4. So this is the same thing as saying 2x times 5. But we don't have anything as u in the initial expression. This is the initial expression. We don't have anything as u there, right? So we have to recall what u is. See what u is. U is x squared plus 1, and bracket close. So I can simplify this further. I can say my final answer is 2x times 5 is 10x, then open brackets, x squared plus 1, or I say 10x cubed, when 10x multiplied by x squared, 10x cubed plus 10x times 1, 10x. So you can leave it in this form or in this form. So, but that's the final answer for that example. Sorry, we're forgetting that this bracket here has a 4 outside, right? 4 outside. So this, rather we leave the answer like this. Answer like this, because we cannot, this is a simplified form. 10x, open bracket, s squared plus 1 all raised to the power 4. Okay, so let's go to the next one. Okay, so now we have another question on the board, and it says y is equals to square root of 3x plus 2. Now this is known as square root chain rule. Now the square root chain rule is also as a function of a function. There's a function inside a function. So we can identify the two functions. That's the one inside first of all. So we say let u, I like to use u, is equals to 3x plus 2. Now when you are determining what your u is, your function inside, make sure that it's a linear or the simplest form without any complication. Just remove, like this one now for this case, remove this square root, because this square root is making it complex. Understand? Then our y and y is equals to u, this u, all square roots. Or you can say, you can express it in power form. Y is equals to u raised to the power 1 over 2. But this is how you should put this, so that you can actually differentiate this one. So the chain rule, function and function, says dy dx. To differentiate this, dy dx is equals to du dx, differentiate this one, and this one, times dy du. You see? So what are split into two? I'm differentiating them one after the other. So at this point, I will look at this one again. How do I write the differential expression for this? Okay, I'll write again. The whole of dy dx, that's this one, is equals to du dx, that's du dx, is 3. 3. By the time you differentiate 3x, you have 3. These two give me 0. You understand? Then dots. Then dy du is, this is the power. The power is, or the exponent is half. Now, this 1 over 2 multiplied by the coefficient, you have 1 over 2, then write u. Then this half, reduce it by 1. That is 1 over 2 minus 1. Okay? So I'm going to complete this one here. So dy dx is equals to 3 times, so I have half, then I have u, then 1 over 2 minus 1 will give me raised to the power minus 1 over 2. Minus 1 over 2. So I can now introduce what I have as my u. My u is defined as 3x plus 2, right? So I will say dy dx is equals to 3. 3 times 1 is 3, then over 2. Then my u will now become 3x plus 2, all raised to the power minus 1 over 2. Now, you know, in our indices, rule of indices, we can resolve this by the minus sign here at the power means that I can bring the whole of this expression under. Okay, so I have 3 over 2 dots. This dot is times, that's times this one. Then I'll now say 1 all over. Because of this minus sign here, the whole of this expression will go down. So it is 3x plus 2, then raised to the power 1 over 2. Again, 3 over 2 dot 1 over, this one is expressed as, this power here, power half, is square root. Then 3x plus 2. So the final answer looks like this. 3 all over 2 root 3x plus 2. So this one is the differential of this. This is the differential of this. So I have this question on the board. It says, let us differentiate y is equals to 1 over, then open brackets, x squared plus 4, close bracket, raised to the power 3. So this is called the chain rule with negative power. because we're going to make this one negative power. But how do we do that? We can write this by saying y is equals to, write this one down as x squared plus 4 all raised to the power minus 3. You see, this expression is something like this. For us to make it linear like this and not be in fraction form, the power at the denominator will become minus. So it's no longer in the fraction form. But again, we can take it back to how it is here by bringing the numerator to be 1 and making this negative power to be positive power. That's plus 3. All right, so but this is how it is now. So at this point, I can now split it into two of the function, the inside function and the outside function. So I will now say let u again be this inside function, x squared plus 4, and y is equals to u. The whole of this is u, right? The whole of this is u. U raised to the power minus 3. So therefore, dy dx is this one, du dx, that differentiate this, dot, differentiate this one too, dy du. Okay, so I'm going to differentiate it one after the other. So du dx differential, look at this like this. So it's 2x dot dy du, this one is this power here will come to multiply the coefficient. So it is minus 3. Note that you are taking the minus sign, down to, yes, so minus 3. Then you have u. Then this power reduced by 1. So it's minus 3 minus 1, right? So we continue here. So dy dx still is equals to, so I'm working on this. So it is equals to 2x, that's this 2x, then times minus 3. Then u, the whole of u, okay, let me write u first, and resolve this one. Minus 3 minus 1 is minus 4. Minus 3 minus 1 is minus 4. That's raised to the power minus 4. So I continue this way. So this one is since as 2x dot, okay, so, okay, let me say 2x dot minus 3, then u, recall, u is what? X squared plus 4. X squared plus 4. So I have minus raised to the power minus 4. So this times this, 2 times 3, minus 3 times 2 is minus 6x. Then open bracket, x squared plus 4 all to the power minus 4. I can bring the whole of this one down. The power will make it come down. So I have minus 6x all over x squared plus 4 all raised to the power 4. So this is the differential for that particular question. You either leave it like this, or you can leave it like this, depending on what you are saying in your objective style questions. Okay, so we have this question on the board. It says y is equals to x squared exponential 3x that we should differentiate. So this is like combining chain rule and product rule. Remember the previous video? Sometimes some functions may involve multiplication and nesting. Okay, so now this is like product rule. So there are two. Recall, we said that when you have two products, two functions, let u is equals to x squared again, and let's say v is equals to exponential 3x. So these are two functions inside one function, and they are products. So what we'll do to differentiate them, dy dx is equals to, you identify the both of them, and you say u dv dx, this, remember this prime is also differential. I told you many ways you can do that. Or you can come and say d dx v. You understand? D dx, that's differential of v, right? This is the way you can write it, but let me use the simple notation. So v prime plus v u prime. See? So you take this one, multiply by the differential of this, plus take this one, multiply by the differential of this. You see, very easy. That's how product rule is. So I'll come again and say, this is u, right? differential of u, u prime is equals to, differentiate this one, you have 2x. Then v prime is, this one is another, is a composite. That's the power here. So this one, to differentiate this, just this 3 will come down and to be 3 exponential 3x. So this is how this one is. So I'm going to plug all this back into this expression. So I have dy dx is equals to, so my u is what? X squared. V prime is 3 exponential 3x. Then plus v is exponential 3x. And u prime is 2x. Okay, so at this point, I will just simplify. I will simplify. It's commutative. I can change the positioning. But then 3 must come first. You write 3 before, you write the numbers before the variable. So I have 3x squared. I'll just arrange it. I arrange the order. 3x squared, then exponential 3x plus, then 2x exponential 3x. So you see I'm having x exponential 3 common to these two terms, right? So I can just group, that is x, you have x and x here, right? You have exponential, you have 3x, you have 3x. So I'll just group it. I'll just bring it x exponential 3x outside, open bracket. So what is left here? What is left here? I have 3x is left plus what is left here? I have just 2. So this is the simple form expression of my equation. I can leave it like this, or sometimes the x can be inside here. It depends on how the answer is arranged, but this is purely the lowest form factor. Some options, you can see it like this. Exponential 3x, open bracket, 3x squared plus 2x. That's the x went in on both ways. The x went into this, and it's appeared from here. So I'm still having exponential 3x. So depending on what you are saying in your options. Okay, so we go to the next one. Okay, so look at the board how we have y is equals to 2x plus 1 sine 5x. So again, we would identify the two functions. This one is still the same thing, but you have trig inside a polynomial. Okay, so this is a product. There are two functions, this function and this function. Okay, so I would say let u be 2x plus 1 and v be sine 5x. So therefore, dy dx is du dx dot dv du. Sorry, dv. This product, this is not function of function. This product rule. So it is like this. U v prime plus v u prime, right? So this one I have u, I differentiate v, then I have v, I differentiate u. So I will just go ahead and differentiate the u and the v. So my u prime, that's differential of u, differentiate u relative to x. What I have is 2x, no, just 2, because this is just, there's no power here, the power here is not greater than 1. So I have 2, right? Now, v prime, or differential of v, that is differentiating v relative to x. I have it as, I'll bring out 5 outside, 5, then differentiate this trigonometric sign. When you differentiate sign, it becomes cos 5x. Okay, now having gotten this, I have this, right? I'll just put them here. Simply substitute them here. So therefore, dy dx is equals to, my u is 2x plus 1. My v prime is 5 cos 5x, right? Then plus, this one is together, plus this plus, Then v is sine 5x. When you are doing this, just follow it gradually. Just plug in all of the values in the respective places. I am here now. I've gotten my v. Then u prime or differential is just 2, dot 2, dot 2. Okay. So here now, I can simplify this. I can simplify this to be, I can write this one first because it's easier. Just bring out this out. Say 2 sine 5x, right? Then plus, plus 2x plus 1, then 5 cos 5x. So this is the final answer. This is the final answer for that differential. Okay. So we have a combination of chain rule plus quotient rule. So this is chain rule down here, then quotient rule up here. So if I have something like this, again, I can do it as a product of two terms. So I can come, I will say, let u, because the product now, y can be something like saying x squared times 1 over square root of x plus 1. Or I will say y is equals to x squared times x plus 1 all to the power minus 1 over 2, right? Okay, so this is product again. Product. See how I resolve this? I resolve this to this. So sometimes when you see some complex expression, first of all, see how you can resolve it to the standard product of two functions. This is actually a quotient. I can use quotient, but on the top, minus top, but I will leave that one first. Because we're looking at chain rule today. So this is it. So I can now say, let u be x squared, and let v be x plus 1 all to the power minus 1 over 2, right? Then I will say u prime, that is differential of u, is 2x, and v prime is this one, minus 1 over 2, then x plus 1, minus 1 over 2, minus 1, dot 1. Dot 1. So this is actually a composite function of a function. So for this one, you see what happened here. I'm just writing it out straightly, but because I've taught you function of function, there's a function inside a bigger function. So the differential of this function inside is 1. That's why I have this one here. Why the composite differentiation is this power comes down to the coefficient. That's why I'm having this one here. And this one reduced by 1. So I have not concluded this one. To simplify this one further, I will just say v prime is equals to minus half, then x plus 1, then this will become minus 3 over 2. So this is the differential of this, right? Okay, so no, not 3 over 2. Yes, it's 3 over 2. Okay, a quick review just shows that it's easier to go through quotient rule directly than to split this into two product functions. So I will take this off. And let's just deal with quotient rule. Remember, I told you quotient rule in the previous video is just to use this simple rule: bottom the top minus top the bottom over bottom square. Okay, so we go bottom. I'll write it out. Bottom d top minus top d bottom over bottom square. Now, where top is numerator, bottom is denominator. Okay, so bottom is this one, right? So bottom, I write the bottom like this. Bottom, then d top, differentiate this top. 2x, right? Minus, then top, again, the bottom, differentiate this one. Remember, this one is the same thing as saying x plus 1 all to the power 1 over 2, right? So differential of this one is 1 over 2 will come down, then x plus 1, right? Then this one to reduce by 1, so minus 1 over 2 minus 1. sorry, 1 over 2 minus 1. That's 1 over 2 minus 1 is minus 1 over 2, right? So this is the differential for this one. Okay, all over bottom square. Bottom square. So this is bottom, then square. Okay, so this can be expressed as, I can take this one in front. So it is 2x, then I will remove these square roots and put the power. X plus 1 all to the power half. Okay, so minus this one to the same thing. I would bring this one out. I will have it as x squared over 2. That's I brought this one out. Then all into x plus 1 all raised to power minus half. Okay, then over, then this bottom square, this square and the roots will cancel themselves out because this root is same thing as raised to power half. Half times 2 is just 1. So what I have is left is this x plus 1 inside, x plus 1. Okay, so this is the answer in its simplest form. Okay, I have everything written. So this is the answer in this simplest form. So this one is rational, functional, composite. It's a composite, it's rational. To differentiate this one is easy. We can rewrite this one like this. Rewrite. Y is equals to, so this one, I want to get rid of it, the numerator. So I'll just write the numerator like this, 3x squared plus 1, then all raised to the power minus 4. So I have it like in a form of a linear form or a composite form, where this is the inside function and you have the outside function. So this one is easy enough. Just say let u be 3x squared plus 1, and y is equals to u to the power minus 4. So dy dx is equals to du dx dot dy du, right? So du dx is 2 times 3 is 6x, right? Okay, this one is 0. Then dot dy du, this one is minus 4u to the power minus 5. Why? Because I'm reducing this power by 1, I'm having minus 5. That is, if you reduce minus 4 by 1, you are having minus 5. That is, minus 4 minus 1 is minus 5, right? And this minus 4 at the same time multiply this coefficient to give you. So this is actually a result. So reintroduce the what u is. Recall that u is 3x squared plus 1, right? So I need to have u in my final answer. We just need to remove it. So dy dx is equals to 6x dot minus 4. Then I will now have u as 3x squared plus 1, right? Just for minus 5. Please remember that one. So this is minus 4. So 4 times 6 is minus 24x. Okay, open bracket, 3x squared plus 1 all to the power minus 5. I can still do this as minus 24x. The whole of this one goes down. 3x squared plus 1 all to the power 5. So this is the final answer for this. Okay. And finally, we'll go into the last for this video. The last set, differentiating exponential and logarithm forms. Okay, so we have on the board y is equals to exponential 2x plus 5. So you have the outside derivative as okay, I'll say let u be 2x plus 5 and v and y be exponential u, right? So dy dx is equals to du dx times dy du, right? So du dx, this one is 2x. This one is the inside derivative. We call it the inside derivative. The outside derivative is exponential u. There's no coefficients to u here, so it's 1 that is there. So 1 will multiply. So, but this is how it is. Okay, so I will now reintroduce my u, because my answer should not be having u. So this cannot be resolved to 2x plus exponential 2x plus 5. So this is the answer. This is not a plus, so say times. Say times. Okay, so this is dots here, right? Okay. And another mistake here is that if you differentiate this one, you don't get 2x. You get x. You get 2, sorry. So it's 2 dots. 2 dots. So this is the final answer. 2 exponential 2x plus 5. Because if you differentiate 2x, you get 2. Okay. So the final one. So we have on the board y is equals to ln open bracket 4x squared minus 1. So you have the outside function and the inside function. So inside function, let u be 4x squared minus 1. And outside function, y is equals to ln u. So this one, straight up, we differentiate dy dx, general dy dx, is equals to du dx. That is, differentiate this first one, times dy du, dy du. Okay, so du dx here is 2 times 4, 8x, right? Then dy du, ln u is the same thing as 1 over u. So this is 8x over u, but u, recall, is 4x squared minus 1. Therefore, dy dx is equals to 8x all over 4x squared minus 1. So this is the final answer for this. So you see that when you see nested function, you use chain rule. So when you see nested function, use chain rule. Remember, chain rule is function of function. Nested function is something like this. You use chain rule. Then when you see multiplied function, right? What do you use? Product rule. When you see divided function, you use quotient, this is product rule. You use quotient rule, bottom the top, my favorite. And often we can see the three are paired together. So the skill is noticing the structure of the function before starting. All right, so there are some TMA questions in the comment section and the solutions. We've come to the end of the class. Kindly subscribe to our channel if you are not yet subscribed to get more of our video. So I hope this video has been informative for you. I'd like to thank you for viewing.